This video is about addition. So we're going to talk about adding whole numbers, we're going to talk about numbers in decimal form, and we're going to talk about numbers in fraction form. And the reason that I'm putting these all in the same video is they're actually really similar to each other in concept. The idea of addition, if you understand what addition is, then you can add in any of these forms of numbers without having to learn more rules, learn a different way. So remember, addition is putting things together. So the question becomes, what can be put together? What am I allowed to put together, and how do I do that? So let's talk about some context. This sometimes helps. So 1 plus 1 equals 2. This is generally understood to be a true mathematical statement. So if I provide some context, 1 person plus 1 person equals 2 people. True. Okay, 1 plus 1 equals 4, not really an accepted mathematical statement, but I can provide context and make that true. 1 person plus 1 person equals 4 arms. I can also provide a situation where 1 plus 1 doesn't equal 2. 1 apple plus 1 building does not equal 2 apple buildings or 2 building apples, right? What do you have 2 of if you have 1 apple and 1 building? So in this case, 1 plus 1 equals 1 plus 1, and that's it. It can't be simplified. In that context, 1 apple plus 1 building just stays 1 apple and 1 building. So the word or the context is something that we're going to call the unit. And we're going to use that word a lot throughout this whole course. So I want you to start getting used to what we mean when we talk about a unit. So to add, we want to add like things. So the 1 person plus the 1 person made 2 people because those were like things. Okay, now sometimes we can change the unit without changing the value of the number. So here I have 1 loaf of bread plus 1 stack of pancakes. Well, 1 loaf of bread plus 1 stack of pancakes doesn't really equal 2, but I can change the unit. Let's say my loaf of bread has 20 slices in it, so that 1 loaf of bread then became 20 bread products, and that 1 stack of pancakes, it had 5 pancakes in it, so I'm going to call that stack 5 bread products. Now my unit is the same, so I have 20 bread products plus 5 bread products, so there's my 25 bread products. Now, stay with me here. Don't tune me out just yet. This is a very important idea, especially important with fractions. So I really want you to tuck this away, this idea of I can change the unit without changing the value. And what I mean by without changing the value is my 1 loaf of bread became 20 bread products because there were 20 slices of bread. So whether I have a loaf of bread or I have the 20 slices that make a loaf, it's the same amount of bread. So the value hasn't changed. My pancakes, 1 stack of pancakes versus 5 bread products, 5 individual pancakes, same thing. It's the same amount of pancake. So what if there is no context, or there doesn't appear to be a context? In other words, the context isn't written out in English after your number. So when adding in decimal form, the unit is related to the place value. And here's what I mean by that. 587 is really 5 what? 500. 8 what? 8 tens, or 80. And then the 7 is 7 what? 7 ones by itself. So if I take 587 and I think of it as 500 plus 80 plus 7, breaking it up by place value, then I can talk about the unit. So 5 hundreds, 8 tens, 7 ones. So now I have my units written out. So let's say I want to add this to 12. Well, let's break 12 up just like we did the 587. So I have 5 hundreds, I have 8 tens, I have 7 ones, and then my 12 became 1 10 and 2 ones. So now, thinking about the unit, then I can start to group them together. So I'm going to put my tens together, I'm going to put my ones together, and then my 100 is going to stay by itself. So I have 500 coming from here. I have my tens coming from 8 tens and 1 10. And then I have my 7 ones and my 2 ones to create 9 ones. And so now I have 500, 9 tens, 9 ones, which is 599. Now, it does look a little big to write it all out like that. So keeping the same principle in mind, I sometimes choose to write it as a set of columns. So every place value, every unit gets its own column. So in the last example, I had hundreds, tens, and ones. So those are going to be my 3 columns. And then I'm going to write in my numbers. So I had 5 hundreds, 8 tens, and 7 ones. That's my 587. And then I had 1 10 and 2 ones. That made my 12. So now I can see within those columns, I know that each of those digits have the same unit. Now I go to add these together. 7 ones plus 2 ones is 9 ones. 8 tens plus 1 10 is 9 tens. 5 hundreds plus nothing is 5 hundreds. So there's my 599. Okay, columns can also be very helpful for carrying. Right? So let's say we have the example 3,627 plus 891. This time for columns, I need to go up to the thousands place because this 3 is in the thousands place. So I need thousands, hundreds, tens, ones, and then I'm going to fill in my 2 numbers. So 3,600, 2 tens, 7 ones. Added to 8 hundreds, 9 tens, and 1 1. And now I will add. This gives me 8 ones, 11 tens, 14 hundreds, and 3 thousands. Now, in the form that it's in, this looks a little bit ugly. This looks a little bit weird. I can't just write 314,118 and say that that's my answer, right? That's not going to work out that way. So what I have to do then is I have to figure out how to carry. So I have too many tens, but I know that 10 tens makes 100. So let's take 10 of these tens and trade them up for 100. If I do that, I now have 110, and now I have 15 hundreds. So the tens place now, I'm all set. I only have 1 digit hanging out in the tens place, but now I got to deal with that 15. So I have too many hundreds, but again, I know that 10 hundreds equals 1,000, so let's trade. Let's take 10 of those tens, and let's move them up to the thousands place. So we often just call this carrying, okay? We're carrying it over to the next column, and the reason that we can do that is because of this relationship. We know that 10 hundreds is the same as 1,000. So if I do that, then in the end, I have 4 thousands, I have 5 hundreds, I have 1 10, and I have 8 ones. So then my answer, 4,518. Now, some of you who were sort of struggling with this unit and why do we do it, you already do it in the traditional algorithm, okay? You already line up your thousands, hundreds, tens, and ones, add them together, and then carry. So this is just showing you why it works and where it comes from, and very important for this particular unit is how it relates to the units. Okay, so I want you to look at this problem and I want you to figure out where the mistake is. Okay, hopefully you notice that you're not adding the same units anymore. This 1 right here is actually in the hundredths place. But this 2 is in the tenths place. So I can't add 100th plus 2 tenths and get 3 hundredths. That's not going to make sense. 100th plus 2 tenths is not going to give me 3 hundredths. So that's where my error is coming in. I am not adding things that have the same unit on them. So columns can be very helpful for helping us line up those place values, which is one of the reasons I like to write the names at the top of the column. Okay, it helps me remember what the unit is and helps me remember to line up those numbers appropriately. So if I go and line these up, now I can see that this is my tens place, this is my ones place, this is my tenths place, this is my hundredths place. So now I have them lined up appropriately. So now my 100th is matched with the 0 hundredths from the 5 and 2 tenths. And the 2 tenths now is lined up appropriately with the 4 tenths above that. So now when I add, I have 100th, because 1 plus 0 is 1. Then I have 4 plus 2 is 6, so I have 6 tenths. 3 plus 5 is 8, so I have 8 ones. And then 6 plus 0 is 6 tenths. So 63 and 41 hundredths plus 5 and 2 tenths is 68 and 61 hundredths. So remember, when you're adding in decimal form, you must add the digits that have like units. So you might find it helpful to label those columns. So what about fractions? This is where more of us are a little uncomfortable. So let's take what we talked about with whole numbers. Let's take what we talked about with decimal forms. Remember what we learned about with respect to the unit, and then let's talk about fractions. So first, please do not try to memorize rules. Memorizing leads to all sorts of issues. If you're going to memorize how to find equivalent fractions, you're going to memorize how to reduce, you're going to memorize how to add and subtract and multiply and divide, trust me, we start to get those confused and mixed up. So let's go for understanding, which means it might take you a little longer, and each question might take you a little longer, and that's fine. It's better that you understand what's happening, then you can do it quickly. Okay, so we need to talk about units. What is a unit when we're talking about a fraction? So let's take 3/8 plus 1/8. Now, the way you read that number, you are actually reading the unit. Just like you did with decimals, same idea here. This is 3/8 plus 1/8. So now notice they have the same unit. So if 3/8 plus 1/8 is 4/8, then rewriting in fraction form, I get 4/8. Okay, so some of you are saying, okay, well that's the easy one. The ones I don't get is when the units are different. Okay, so here's an example where the units are different. My first number is 1/3, so the unit here is thirds. The second fraction is 4/9, so the unit here is ninths. Well, thirds and ninths are different. So let's make them the same, right? We have already talked about how to find equivalent fractions, how to take a fraction and break it up into a different number of pieces. I'm going to revert back to drawings. I'm always going to draw my fractions. I love drawing my fractions. I think it is so helpful. So we're going to do this here. So we're going to start by drawing 1/3 and 4/9. So my 1/3 is the red. Notice I broke it into 3 equal parts and I shaded one of them. And then my 4/9 is in the blue. So I took the same size hole, the big rectangle for the blue shading is the same as the big rectangle for the red shading. I broke the blue one into 9 equal parts and then I shaded 4 of them. So now I need to figure out how to add these together. Well, in the form that they're in, it's difficult to add them together. I'm not sure where to put the red one inside of the blue. I'm not sure where to put the blue inside of the red. So let's change them to the same unit. So I'm going to take my 1/3 and I'm going to turn it into ninths. Okay. It's fairly easy to break thirds into ninths. So that's the process I'm going to use. So now, keeping the same amount shaded, I just drew 2 horizontal lines so that now my whole has 9 pieces inside of it. Now I can see that I have 4 pieces in the blue and I have 3 pieces in the red. So now I actually have changed what I'm trying to add. Instead of saying this is 1/3 plus 4/9, we can say this is 3/9 plus 4/9. Okay, well now I have the same unit, 3/9 plus 4/9. So either at this point we could go ahead and write the answer, or I like to continue the drawing. If I go ahead and put them in the same hole, so I have my 3/9 in the red, I have the 4/9 in the blue, so now I have 7 shaded, 9 in the hole. So 1/3 plus 4/9 is 7/9. So what about mixed numbers? So situations where we have a whole and we have a fractional part and we're trying to put those together. It's the same thing. Do not make this question any more complicated than the previous questions. Draw them out. So in the orange, I drew 3.5. So I have 3 whole boxes shaded in and then half of that last box. So I broke it into 2 pieces, shaded 1. In the green, I have 2 2/3. So I have 2 whole boxes shaded in green and then 2/3 of that last box. Broke it into 3 parts, shaded 2 of them. And now I just need to add these together. So my answer is just all of the shaded part, all of the orange and all of the green put together. Well, I start by sort of putting all my holes over together. Now, often when I'm drawing these out, I kind of just circle the holes and write a number next to them. I don't necessarily redraw them. Okay, so here I have my 3 holes from my orange and I have my 2 holes from my green, so that's 5. That part is already set. So the part then that I need to work on is these 2 fraction parts. So now the smaller orange part and these 2 smaller green parts. Now, right now, visually, very hard to add these together because they're not the same size piece. So let's go ahead and make them the same size piece. So now notice I took the top rectangle and I broke it vertically. I took the bottom rectangle and I broke it horizontally. So now let's switch it. So let's break it in the orange rectangle into thirds horizontally and the green rectangle into half vertically. So now, even though those lines aren't totally lining up, both of these 2 rectangles are broken into 6 equal parts. So now I have sixths. So I've changed this question to now be 3/6 plus 4/6. I've created the same unit. Now, I'm going to continue with my drawing to see what happens. So I'm going to take these little pieces and I'm going to put them together. So notice I put my 3 orange pieces, I kept them in the box, and then I filled that box. So I took 3 of these green pieces and I stuck them over here to complete an entire box. And then this last box here gets put in a new hole all by its little lonesome self. And that's fine. So now what do I end up with? I end up with 1, 2, 3, 4, 5, 6 holes that are completely shaded in. And then this last box, 1 box shaded, 6 in the hole to give me a 6th. So 3.5 plus 2 2/3 is 6 1/6. Summary. When adding, it is helpful to only add digits with the same unit. And we're going to stress that word unit. When we're talking about decimal form, the place value determines the unit. Whatever place value that digit is sitting in, that determines the unit. In fraction form, the size of the piece determines the unit. And we are assuming that the holes are the same size. We assume that unless they tell us differently. Okay. It might be easier for you to think about the size of the piece differently. It's the number of pieces in the hole that determines the size of the piece, which is determined by the denominator. So the denominator tells you how many pieces are in a hole. That tells you the size of the unit.